Alright, what's up YouTube, and welcome to the first part about making a balancing robot using the Arduino microcontroller. So what I've done is I've used two servo motors and Arduino with a 9-volt battery to power the Arduino itself and a 6-volt battery to power both the servo motors. The wheels that I'm using are two of the same, obviously. 3D printed wheels. I've 3D printed these at school. The diameter is 12 centimeters, I guess. It's the same as as a CD. The 6-volt battery are like four separate 1.5 AA batteries, and then taped together with isolating tape and soldered. I soldered the connections. I'm not sure if you can see it right here. So my first thought was that if the point of mass will be as low as possible, that it would be the easiest way to get it in balance. Like you see these videos where in circus acts they have a bike with someone on it biking over a rope and then a big counterweight hanging under it to make it stay in balance. But I've found out that it's not really the same case when you're using the Segway-like balancing robot. You want the height being as high as possible so you can control it easier with little steps. So the bad thing about my design is of course the servo motors, because you can only rotate them to a certain amount of degrees. In this case, I guess it was like 120 degrees. Some of them are hackable, so you can rotate them continuously, but I'm not sure if it's possible with this one. Maybe someone knows. It's the Tower Pro MG946R. Yeah, so I'll power it on. As you saw what I just did, the balance is pretty good, the mass itself, because you can see it can stay on itself in a balanced position, yeah, without even being turned on. Yeah, I'll power it on right now and get the camera a bit zoomed out so you can see the whole robot. So now you'll hear the servos turn on, yep. Oh, and I'm using the MPU 6050 gyroscope, by the way, with 6 degrees of freedom. 7 if you count the measuring of degrees with it. Alright. So this is the balancing robot. As you see, it does react to rotational force of the gyroscope. What I noticed is that the 6-volt battery gets too low power after a really short use. So yeah, that might be because I made it myself, but I've got another one already. And the battery, like this one, the batteries aren't empty, but they just don't give enough power to power the servos. Alright, so I'll put it down for a sec so you can see. It does almost do the job. Like sometimes a few seconds. So this is like the very first prototype I made, and I'm gonna make another one with a higher center of mass. Yeah, this right. So another problem is with the servo motors that they can't turn continuously. So once it has been like pushed to one side, you'll notice that it will drop anyway because the motors are limited. and it's the same on the other side. So you can expand the range where it can balance by making bigger wheels with a bigger diameter. But it should be able to just stand in a place like with a little range. Yeah, so I'm using the MPU 6050 gyroscope from eBay. Another thing I noticed is that the gyroscope has to be placed on the axis between the wheels, so it will be like here behind the battery, because now it gives a noise because of the range between the axis of the wheels and the gyroscope itself. It uses acceleration to calculate the exact degree it's in. Yeah, the case that I have is like it was a starter kit for Arduino. I had to buy it for school, and I found out the Arduino with this case fitted almost perfectly in it, and the servos, yeah, came around very nice too. So I thought I'd make it with this one, the first prototype. But I think the next one will be made out of wood. Yeah, the controlling of the servo motors is like it's both the same but the other way around, because the servos are rotated 180 degrees from each other. And yeah, that's pretty much it. The gyroscope is also powered by the 9-volt battery at the back of the machine, and going through the 3.3 volts on the Arduino. So yeah, I will make a part 2 with a hopefully better working robot. And see you next time. Thanks for watching. Please leave a like and subscribe if you like to see more.